Hello everyone and welcome to RouteRush Island, which is a gamified pathfinding simulator that turns dry textbook algorithms into an immersive, interactive experience. This isn't just another DSA project. This is Dijkstra, Bidirectional Dijkstra, Bellman-Ford and BMSSP performance simulator competing in real time on a tropical island with dynamic traffic, ocean waves and sea creatures. In the next few minutes, I will show you exactly how to use every feature of this tool, from setting routes to dropping accidents on roads. Let's dive in. Let's focus on the overview of the interface. When you first launch the RouteRush Island application, then you will see this beautiful split screen interface where the left side has the tropical island map with nodes representing junctions and edges representing roads, and the right side has a control panel with all the simulation controls, and the top bar shows the application's names along with the current graph size, node indicator and theme toggle button. Notice the island aesthetic here. The we have gradient coastlines, animated ocean waves and even sea creatures swimming around. All this simulates real life like scenario. RouteRush Island inherently supports both light and dark modes for comfortable viewing. To toggle, you can click this moon or sun icon on the top right corner or press T on your keyboard. Watch how the entire color palette changes. The island becomes lighter with different color schemes. The ocean gets light blue and the UI adapts beautifully. And on toggling the button again, you switch back to dark mode. I personally prefer the dark mode as it gives a more visual contrast while using the tool and is uh, more better for visual aesthetics. Let's start with setting up our first route. This is where the actual pathfinding begins. For doing the same, we need to use this section of the control panel of setting our route where we have two buttons, set start and set end. We can click the set start button and randomly select any node on the graph as our starting point. So suppose if I select this node, then this becomes my starting point and is marked with a green symbol. And to select the destination, we click on the set end button and select any random node as our destination. So if I click here, this becomes my new destination and the algorithms automatically find the path from source to destination behind the scenes. Now this was for a simple graph, but you can increase the number of nodes here to simulate big cities like we have nowadays, where the source and destination can be changed as per your choice. So suppose if I select set start and click here, then this point is marked as my starting point, and again set end here and click this node, then this point is my new ending point, and the algorithm automatically finds the most optimal path depending on current traffic conditions, uh, simulated using dynamic weights across the nodes in this application. But this is assuming a normal scenario with baseline traffic and minor changes, where the current traffic intensity is set to 50%. But in real life, we can have different kinds of scenarios, like at a particular point of time, it may be a rush hour, or there can be accidents at certain roads, or construction going on at certain roads, or something truly unpredictable. So, to take into account all these scenarios, I have provided 5 options here: normal, rush hour, accident, construction, and random events mode. So, if I select rush hour mode, then the main roads, as you can see here, are marked with yellow color. Notice how the edges turn orange and red as the congestion builds. We also have a accident scenario option where we get a small panel with a enable accident selection button. On clicking this button, the accident selection mode becomes active and you can randomly select any road on the graph to mark it as an accident road. So, as you can see here, now on clicking a particular road, I got two options, 59 to 60 or 60 to 59. Which one do I need to block? So, this simulates real life as accidents can happen on one way only. So, depending on the direction, we can select the particular way. Like suppose I click here 59 to 60, then that particular way is blocked and automatically the algorithm reroutes the path, finding the next new quickest path to reach from source to destination. Like this, I can select multiple paths and mark them as accident routes. As you can see here, now selecting the accident mode here, even though the accident got applied, but the path was not rerouted. This is because for the particular case, from going from source to destination, the path where accident actually happened was opposite to the direction that the user wanted to travel from source to destination. That's why there was no need to reroute the path as it didn't come in the way of user while he went from source to destination. To undo your accident selection changes, you can click on this undo button, or if you want to clear all the applied changes, you can directly click on clear all button. This clears all the roads that you marked as accident here. A point to note here is that once I mark a road as an accident road, then no dynamic weights can flow across that particular road, and that's why that road becomes completely blocked. But what if we want to simulate very slow moving traffic? Then we have to enter the construction selection mode and a short panel appears like the accident selection mode for enabling construction selection. So suppose if I click here, then I can mark any road like accident selection mode for construction. So suppose if I click on this node, then this particular road is marked for construction and the path is rerouted. But a subtle point to take note of here is that this road has very slow moving traffic, but it doesn't completely block it. So if we make multiple construction selections across this entire map from all the possible paths from source to destination, even then we will get a particular path that will help us reach from source to destination. Whereas if the same case was with accident selection, this might not be the same case. Like this, you can mark multiple roads as under construction by selecting the edges. Like suppose I click here and mark this for construction, then this particular road is marked for construction and the depiction of it is shown via a oscillating hammer here. Let's clear the current changes and let's look at the next traffic condition mode that we have here, that is random mode. So first I click the reset button and enter the random selection mode. As you can see here, under the random selection mode, the accidents and constructions happen randomly at any point in the graph, and the default rates for accident and construction chances are set to 10%, but the user can adjust this as per his convenience. Like he can make it to 0 or he can make it to 52%. But the risk here is that for increasing accident chances, the algorithms may not always succeed to find a viable path as it may not be available due to complete blockage. Like here, I got a message that no path found and try a different route. So to solve this, I keep the accident chances low and even the construction chances low. Since the conditions are random, the path always fluctuates. But in real life, uh, this scenario is taken into consideration by showing multiple paths available, and the path which is most frequently selected as the shortest path is shown as the fastest path for that particular instance. Let's switch back to the normal mode and look at the other features of the control panel. In the third section, we have the choose the drivers section where you can select or deselect the algorithms which you want to implement on the graph for finding the shortest path. So, suppose if I select this box, then Dijkstra becomes unavailable, and if I select again, it becomes re-available. Now you will question me that why isn't this change appearing here? Because by default, the path path color which is shown is the color of the algorithm's path, which finds the uh, path from source to destination in the least amount of time. So since BMSSP is the most optimal algorithm here, so its color is prominently shown for showing the shortest path from source to destination. So if I deselect the BMSSP path, you can see that Dijkstra, which is the second optimal algorithm for solving our particular problem, its color is shown here. And if I uncheck it, then bidirectional Dijkstra's path is shown. And finally, Bellman-Ford's algorithm's path is shown. All the algorithms help us find the uh, path from source to destination. But as always in real life, we want uh, to finish tasks in the smallest time possible, and the color that's why the algorithm, that is BMSSP, is chosen to find the shortest path from source to destination in least amount of time. Beneath this section, you can see another section where you can see in real time that the amount of time taken by the algorithms to find the path and the estimated travel cost, that is distance from source to destination along the shortest path, and and alongside the trophy symbol, the algorithm's name along with the time taken by it to find the shortest path is shown, which finds the path from source to destination in the minimum in the minimal amount of time. Now let's look at the other simulation controls under the control panel. First, we have the traffic intensity slider, where we can increase or decrease the amount of traffic on the roads. And as you increase the traffic, the edges turn more yellowish, depicting increased congestion over those roads. And as you decrease, they become more lighter and neutral. Next we have are the two buttons, that is pause simulation and resume simulation button. What these two buttons do is that on clicking pause simulation, the all these simulations are paused and all the times and travel cost calculations are stopped immediately, and the whole simulation immediately stops for the moment. And on clicking resume simulation, it resumes back and the algorithms start their work again, analyzing the current traffic conditions and finding the shortest path. On clicking reset traffic, the traffic conditions are restored back to their original state which we had on opening the application. For navigating on this map, you can use the plus symbol to zoom in or minus symbol to zoom out or reset symbol for a standard interface for comfortable node selection of, of source and destination. Additionally, to move around the map, you can use the W key for moving up, S key for moving down, A key for moving left, and D key for moving right. And for restoring back to original view, you can simply click R, which acts as a shortcut for the reset view button that is here. Now look Now let's look at the audio features which make the RouteRush Island truly immersive using tone.js library. So on clicking the enable audio, you can immediately hear ocean waves, pink noise filtered for realistic wave sounds, and wind ambience, brown noise representing traffic hum and wind. Wave volume can be controlled using this slider where you can move it further to increase the density of the waves around the map, or you can decrease it as per your convenience. And this sound feature is not only about waves and winds, it, it is also applicable for accident and construction selection modes. Like now I click the enable audio button, so if I again enter the accident selection mode and enable accident selection, then on clicking the particular road and selecting it as blocked road, immediately a pop sound can be heard marking the road as accident marking the road as accidented. And in the same way, on entering the construction mode and selecting the enable construction selection button, after selecting the particular road for construction, a beep sound is heard after our node is successfully marked for construction. This was all about the audio features. Now let's talk about the island aesthetics. Let's appreciate the tropical island aesthetic that makes this more than just a graph visualization. The island has three gradient colors. Outer edge has sandy yellow, middle has orange transition, and inner has light yellow. Green to lime gradient represents vegetation here. Next, we have animated ocean waves that spawn symmetrically using golden angle distribution. They travel towards the island center. They essentially travel towards the island centers. Waves morph, start compact, stretch to 8x as they approach shore. Thickness tapers from 8 pixels to 1.5 pixels. Color shifts from deep blue to cyan to white foam. When waves collide with the island or each other, they splash and fade. This is all about the animated ocean waves. Now let's talk about the sea creatures. We have particular two types of fishes, as you can see here, an orange fish and a blue fish. And we even have sharks. This is done to simulate a more real life scenario and provide an immersive experience. Next, we have a coconut tree line bordering the island, which marks the boundary of the green vegetation. This is dynamically generated based on distance from island edge, and it creates visual depth. Next, you can see the pulsing glow effect, that is from source and destination nodes have a pulsing glow effect. Like you can see, the green color is first expanding and contracting, and the red color at destination is also expanding and contracting. This creates a visual hierarchy and helps us clearly identify the source and destination for our particular journey. And that's all about RouteRush Island, which is a complete educational visualization tool that turns pathfinding algorithms into an immersive experience. Key takeaways: in this video, we covered light dark mode theming, dynamic source or destination selection with city size scaling, 5 traffic scenarios with a manual incident placement, 4 algorithm comparisons with real time metrics, live simulation controls like pause, reset, uh, and camera, immersive audio with wave and wind sounds, and beautiful tropical island aesthetics with animated waves and sea creatures. An important disclaimer here is that the BMSSP algorithm implemented here is a performance simulator, not an actual implementation. It uses bidirectional Dijkstra under the hood, then simulates what BMSSP timing would look like based on theoretical complexity. This tool is only meant for educational purpose and does not replicate a production grade system. You can get the GitHub link to view the code and getting the necessary installers for installing this particular app on your device like Windows, Linux or Mac OS. And you can also get the Medium blog description in the YouTube description where I have in detail described my entire journey as to how I built this educational tool for everyone. Thank you.